This is section 3.9, exercise 34. This is the application. And they tell us about Ohm's law. A current of I amperes passes through a resistor of R ohms. And they tell us that our voltage E is related to the current in the resistor, or another way to put it is the voltage drop over the resistor is just I times R. And they say, okay, the voltage is constant. Show that the magnitude of the relative error in R caused by a change in I is equal in magnitude to the relative error in I. Okay. So I got to think about that for a second. What are they saying? They're saying that I guess if we are trying to do our error, they're saying, I think what they're saying is, if I want to look at the differential in the voltage, that is going to be I times the differential of R plus R times the differential of I, or well, the dI, dr. So we're using the product rule idea here for the differential. And they're telling us the voltage is constant. Okay, so if that's the case, if E is equal to some C, a constant, well, then the differential of E is going to be 0. Okay, so we have 0 is equal to I dr plus R over R times dI. And so, and they mention the magnitude of the relative error in R caused by a change in I is equal to the magnitude of the relative error in I. Well, okay, so what they're really just getting at, I think, is if I manipulate this a little bit, right, I can write this as minus dr times I is equal to R dI. And if I divide both sides by I and both sides by R, I get minus dr over R is equal to dI over I. And so if I take the absolute values of everything, that's dr over R is equal to dI over I. And these are both the relative errors. And again, it says show that the magnitude of the relative error in R, okay, there's the magnitude of the relative error in R, caused by a change in I. Okay, so if I changed I, that would be the dI, is equal to the magnitude of the relative error in I. Yeah, so if I look at here, I've got the magnitude of the relative error of I. So I think, you know, they're just getting at that relationship when I have that the voltage was kept constant. So its differential would be 0. Okay, and that is exercise 34.